Alright, so in this video we're going to talk about 12 basic parent functions that we need to be familiar with for precalculus. Okay, so our 12 functions for precalculus with which we need to be familiar are going to be listed here. Okay, now importantly, we must be able to, for these 12 functions in particular, and then for other functions as we go on, be able to identify the domain, the range, and any continuities or discontinuities. We should be able to identify intervals where our function is increasing. We should be able to identify intervals where our function is decreasing. Okay? Now, boundedness is also something to consider as well as in behaviors. So for example, our exponential function, it's always increasing. Okay? Now we'll talk about making transformations that'll change that, but we can identify that it's always increasing. It happens to be bounded below. We can talk about the domain and the range that would be associated with it. Okay? Now the identity function, y equals x, is a special form of the linear functions, right? We should be familiar with linear functions in general, but in particular, this identity function is y equals x. Okay? We have the quadratic functions, such as y equals x squared. All right, and we can see that on quadratic functions, we have portions where we are decreasing, and then other portions where we are increasing. Right? We do seem to be bounded below for this particular function, and unbounded above. Right? That the end behavior, as x goes to infinity, the function goes to infinity. And as x goes towards negative infinity, right, if I go to the left end behavior, the function is still going towards positive infinity. Okay? This is a function here that you may or may not be familiar with, the greatest integer function, and it is simply a function that takes on the value of the most recent integer that the function has, the input has passed. So for example, if I input any value from 0 to 1, right, the output will be 0. But if I have an input from 1 to 2, the output will be 1. Okay. Now it is important to note that sometimes the greatest integer function is called the floor function. Okay. And if the input is an integer, the output is that same integer. So at 2, the function is actually equal to 2. But at 1.9, the function would equal 1. Okay. Logarithmic functions we need to be familiar with, right? The standard logarithmic function has a domain greater than 0, right? X has to be positive for the input, but the range is all real numbers. Okay? These sinusoidal functions are functions that you may not have seen previously. They're functions we're going to work a lot with this year, and we'll talk about the sine function and the cosine function. But the interesting thing about the sinusoidal functions is they have this repeating pattern, right? We call that being periodic. Okay, we can clearly see that we're bounded above and bounded below, so this would be called a bounded function. The domain would be all real numbers, right? But you'll be left to be able to get that information further. Now, next we have our additional functions here, right? We've covered 6. So before we cover the next ones, right, I want you to consider the following when you're looking at the graphs of these 12 basic parent functions. Okay? How would the function attributes change if you were to move the functions up, down, left, right? How would those function attributes change if you were to stretch or compress the functions, vertically or horizontally? How would you group functions for these based on similar characteristics? And additionally, what type of symmetry seems to be present for these graphs? So for example, this cubic function here and this reciprocal function here have a rotational symmetry, right? That if I were to rotate these around the origin, I would end up looking at the same graph, okay? But still, domain, range, we need to be familiar with. Continuity, discontinuity. It seems we have an infinite discontinuity here with the reciprocal function. Okay, got to keep those things under consideration. We have the constant function y equals k. It's simply a horizontal line because our function is constant. It does not change value. Right? We have this cubed root function that looks like a little bit like an s, and there's going to be another function that's called the arctangent function that we look at later on this year. It's going to look very similar to this cubed root function, but it is important to note that this cubed root function is unbounded. Its range is all real numbers, and so is the domain. Okay? And lastly, we have the absolute value function whose outputs are always positive, right? Gives us the magnitude. And then the square root function, which is the square root of x. And of course, we could move this function up, down, left, right. Okay? These are the 12 basic functions with which you need to be familiar and be able to answer these different questions about domain, range, continuity, discontinuity, intervals where you're increasing or decreasing, and your boundedness and your behaviors. Thank you for your time.